This is the first homework of Chapter 2, Physical Chemistry 1. Question 1. A cup of water at 278 Kelvin is placed in a microwave oven, and the oven is turned on for 1 minute, during which it begins to boil. Which of Q, W, delta U are positive, negative, or zero? Well, let's begin with Q. When microwave oven is turned on, microwave provides heat, and water in this case is the system absorb heat, and therefore the heat is positive. Now when water is heated, liquid water does not change much volume. However, it says it begins to boil. So when water boils, it forms vapor phase. The volume increases dramatically when the phase transition occurs. And when the volume increases, it does work to the surrounding, and the work is negative. For delta U, we need to think about the kinetic energy and the potential energy. Because temperature increase, that indicates kinetic energy increase. Now, for potential energy, because liquid becomes vapor phase, the intermolecular distance increase, and therefore potential energy also increase. Now think about you throw an object into the air. The potential energy in physics is mgh. So if you increase the height, the potential energy increase. Same thing is here. When liquid becomes vapor phase, potential energy increase, and therefore the internal energy increase. Question 2. 3 moles of an ideal gas at 27 Celsius expand isothermally from an initial volume 20 cubic decimeter to a final volume 60 cubic decimeter. Calculate W if this process is A. Expansion against the constant external pressure, and B. A reversible expansion. So for A, because its external pressure is constant, the equation is negative pressure times volume change. Okay, remember, constant pressure process. The work is negative pressure times volume change. The pressure must be external pressure, and therefore you use negative. Okay, don't forget the negative sign. 1 times 10 to the 5th Pascal, that's the pressure, times volume change from final. The final is 60 minus initial, 60 minus 20. The cubic decimeter you need to times 10 to the minus 3 to change to cubic meter, so that Pascal SI unit, cubic meter SI unit, and that gives you joule. Okay, so that's A, constant external pressure. For B, reversible, and we also see this is isothermal. So whenever it's isothermal reversible, the work is negative nRT ln V final minus V initial. Okay, remember, constant temperature, reversible process. The work is this equation. So remember, negative nRT ln V2 over V1. Okay, so plug in everything. N is 3 moles, T is 300, constant 27 degree, that's 300 Kelvin, ln V2 divided by V1. Now, in this case, you don't need to change to cubic meter because it's a ratio. As long as they are in the same unit, you are fine. And that gives you negative 8.22 times 10 to the 3rd power joule. Question 3. An ideal gas described by initial temperature 300 Kelvin, initial pressure 1 bar, initial volume 10 liter. It is heated at a constant volume. Okay, so note the keyword, constant volume, until P2 is 10 bar, and then it undergoes reversible isothermal expansion until P3 is 1 bar. It is then restored to its original state by extraction of heat under constant pressure. So 3 processes: constant volume, reversible isothermal expansion, constant pressure. For this kind of question, it's very useful if you can draw the PV diagram first. Okay, so let's see how it looks like. So you have initial P1, T1, V1. So if this is pressure, this is volume. Okay, so you have initial point right here, and it's heated at constant volume. So constant volume means vertical line. The volume doesn't change. So if this is initial state, this will be the P2, V2. So here you have P2, alright, and the V doesn't change, constant volume. So V2 equals V1, V initial. So this is P1 or P initial. Okay, and then undergo isothermal expansion. So that's isotherm looks like this until becomes P3. So the reason P3 is 1 bar. So note that 1 bar equals initial pressure. So here same. That's P3 and V3. So P3 here is P1 and V3. It didn't say, so you need to calculate. And then the third process is go back on the constant pressure. Okay, so you go this way. So, all right, so constant volume, constant temperature, and constant pressure, 3 processes. So let's look at a better drawing. Alright, so 3 processes: constant volume, constant temperature, and the constant pressure. Now, how do we calculate the work? For constant volume, because volume doesn't change, the work is 0. Now, second process, if it's constant temperature also reversible, the equation is negative nRT ln V2 over V1. V final divided by V initial. Here, final is V3, and the initial is V2. That's why it's V3 over V2. Okay, and the third process is constant pressure. So constant pressure, work is negative pressure times volume change. And here, volume change is final minus initial. In this case, this is initial. Is actually the final volume for the third process. And here, the V3 is the initial volume. From V3 goes to Vi. So that's why it's V1 minus V3. So we have all the equations, but to calculate, we still need to find the number of moles. It doesn't tell you. The temperature T2, we need to find out. And the V3, we need to find out. So this is a typical question in this chapter that you have to go back to chapter 1, use gas laws. How do you find the N? If you look at the initial state, you have temperature, pressure, volume, and you can use ideal gas law to calculate number of moles. So PV equals nRT. To calculate number of moles from the initial state. How do you calculate T2? Okay, so note that T2 temperature is all the same. And so here you have a T2. Right? Here you have T3. But T2 is equals to T3. If you look at the initial state, you have P1, V1, T1. You have P2, V2, T2. And we know P1, V1, T1, P2, V2, we don't know T2. And therefore you can use combined gas law. So P1, V1, T1 equals P2, V2 equals divided by T2. So from this equation, T2 can be calculated. How do you calculate V3? Well, because the second step is a constant temperature, so constant temperature is isotherm, it's Boyle's law. So P2, V2 should equal to P3, V3. And therefore, V3 can be calculated. So you have to use the ideal gas law, combine the gas law, the Boyle's law to find out the number of moles, T2, V3. Now to the last step, constant pressure, you need a V1 and V3. V1 is given, but V3, yes, so you already calculated, use this. So here also calculated. This slide shows the detailed calculation. First, ideal gas law to calculate number of moles, and then use combine the gas law to calculate the T2, and then you can calculate the second step work, the reversible, isothermal reversible. Now in this case, actually, you don't have to calculate the V3. The reason is you can use Boyle's law. Instead of V3, V2, you can use P2, P3. Okay, because Boyle's law. P2, V2 equals V3, P3. We know the pressure, and therefore we don't have to calculate V3. Now in the third step, you have to find the V3. So use Boyle's law to calculate V3. And then you calculate W. It's P3, P1 minus P3 in this case. Okay, so you can calculate work. Okay, so I strongly suggest everyone try this question on your own without looking at my answer key, and then compare to the answer key. Okay, bye-bye.